Hi everyone, I am P. Ramesh, Assistant Professor, Department of Mathematics, Dr. SNS, Rajalakshmi College of Arts and Science. In this lecture series video, we are going to discuss about the large sample test from quantitative methods for management. So first, large sample test. So it's a test of significance for large sample. First of all, what is the meaning of large sample? When the sample size from the population is greater than 30, then it is called a large sample. So under larger sample test, we will see six important tests to test the significance. The first one, test of significance for single mean. Second, testing of significance of difference between two means. Third, test of significance for single proportions. And fourth one, testing of significance for difference between two proportions. Fifth one, testing of significance for single standard deviation. Sixth one, testing of significance for difference between two standard deviation. So first, test of significance for single mean. So let us take small x1, x2, etc. xn be a random sample of size small n from a large populations, and a capital x1, x2, etc. xn of size capital N with a mean mu with the variance sigma square. Here x bar is sample mean, mu is population mean. The first step, we form the null hypothesis. So null hypothesis H naught is the sample mean and population means these two are no significant difference. That is no significant difference between population mean and sample mean. Okay, the step two, alternative hypothesis, that the sample mean and the population means are not different. Uh, that is H naught, and if it is different, that is H1. Next, the third steps, compute the Z statistics. The Z statistics is x bar minus mu divided by sigma by root n. Suppose if it is negative, we form the modulus. Okay, that is if a modulus is a, that is a statistics value, and which one is less than the critical value, then we accept the H naught. Otherwise, we reject the H naught. So we discussed some three problems. The first one, a sample of 400 individuals is found to have a mean height of 67.47 inches. Can it be reasonably recorded as a sample from a large population with a mean height of 67.39 inches and standard deviation 1.30 inches? So what are they given here? Here, the sample size n is 400. Therefore, it is a large sample, and the sample mean is 67.47. The population mean is 67.39, and the population standard deviation is also given, it is 1.30. Now we form the null hypothesis. The population mean is 67.39. It is, that is, they assume there is no significant difference between sample mean and population mean. Yes, we check test using the statistics, Z statistics. So modulus Z is already we have this x bar minus mu divided by sigma by root n. So we substitute all the values here. X bar, that is sample mean, is 67.47, and the population mean mu is 67.39 divided by standard deviation, that one is population standard deviation is 1.30, and the number of data are 400, that it is root 400. After reducer we get 1.23. At 5% level of significance, the tabulated value Z naught is 1 point, Z alpha is 1.96. Since the modulus Z is less than Z alpha, that is equal to 0.05. So we accept the null hypothesis. That is, the 1.96 is a critical value, 1.23 is a calculated value. Since this calculated value is less than the critical value, therefore we accept a H naught. So we conclude that the sample has drawn from this population. We discuss second problem. An ambulance services claims that it takes on an average 8.9 minutes to reach its destination in emergency calls. To check on this claim, the agency which licenses ambulance services has them time on 50 emergency calls, getting a mean of 9.3 minutes with a standard deviation of 1.6 minutes. what can they conclude at 5% level of significance? So it is a situation. So now we find the solution for this. What's the conclude? Here they already given the population mean mu is 8.9 minutes and the number of calls is 50. Therefore, n is equal to 50 and the sample mean is 9.3. That is sample standard deviation small s is 1.6. So now we form the null hypothesis H naught mu is equal to 8.9 minutes. We check it whether it is correct or not. So test statistics is modulus Z is modulus of sigma x bar minus mu divided by sigma by root n. Substitute all this value. Sample mean is 9.3 minus population mean is 8.9 and the standard deviation is 12.6. The number of calls are 50, therefore root 50. After reducer, we get the answer 1.768. Since it is a calculated value, the critical value is 1.96. So that this tabulated value is at the 5% level of significance for largest sample is 1.96. So this value is less than the critical value. Therefore, we accept the H naught. So we conclude that the average time taken to reach the destination in 8.9 minutes. Therefore, the the ambulance reached the destination at 8.9 minutes. That's the conclusions. Next, we have the third one problem, testing of significance for difference of means. Okay, so here, let the x1 bar be the mean of sample of size n1 and the x2 bar be the mean of sample of size n2 for another and a population with the mean mu2, mu2 with a standard deviation sigma. So we have the large sample, hence under the null hypothesis, these two samples are equal. This two mean value, as the sample means are equal. That is, mu1 is equal to mu2. The test statistics is z is equal to x1 bar. So the test statistics is z is equal to x1 bar minus x2 bar divided by root of sigma 1 square by n1 plus sigma 2 square by n2. So let us go to the problem. Two samples of cables of size each 100 are taken in order to test breaking strength and their mean and standard deviations are given. The first cable average is 1925 and its standard deviation is 40. Second cable average is 9005 and the standard deviation is 30. Test whether means breaking strength of the two cables are equal at 1% level of significance. So what are the given? The null hypothesis is mu1 is equal to mu2. These two samples are equal, averages are equal. That is, there is no significant difference between the mean breaking strength of two cables. Alternative hypothesis, these two are not equal. So level of significance at 1% level, that is 0.01. So computations of the test statistics is it is x1 bar minus x2 bar by sigma 1 square by n1 plus sigma 2 square by n2 of all into the root. It's a normal value 0, 1 with the mean 0 and the standard deviation 1. Okay, here we substitute all the values here, then the Z statistics value become 4. Tabulated value of Z at 1% level of significance for two-tailed test is 2.58. Since since the table value Z is greater than 2.58, because the calculated value is 4, table value is 2.58, therefore the null hypothesis become rejected. That is, we conclude that the mean breaking strength of the cables are differ. And denote that suppose the H naught mu1 is equal to mu2 if the samples drawn from the same populations where the standard deviations are equal, that is mean are different and the standard deviations are equal, that is Z is on this type of situations Z is x1 bar minus x2 bar by on sigma 1 sigma 2 both are equal, then it is called it is sigma. So take out sigma from the root. So is a x1 bar minus x2 bar by sigma into root of 1 by n1 plus 1 by n2. That's value. So we discuss a problem. In an university, 70 junior students are found to have a mean height of 64.5 inches, 60 seniors of mean height of 65.4 inches. is that evidence conclude that the mean height of the seniors is lower than the juniors. Assume standard deviation of the height of the university students to be 2.48 inches. Okay, we check it. The solutions, what are they given? So here the null hypothesis H naught is mu1 is equal to mu2. There is no significant difference between mean height of juniors and the seniors. Okay, we check it. Alternative hypothesis mu1 is greater than mu2. That is the height of the senior student is lower than the junior students. Okay, level of significance is 5%, that is 0.05. Okay, compute Z statistics. Z is x1 bar minus x2 bar divided by sigma by root of 1 by n1 plus 1 by n2. Okay. So substitute all this value here, we get a minus 0.01215. So we get the modulus that is positive value is 0.012. That here it is a calculated value. Since the critical value or the tabulated value at 5% level of one-tailed test is 1.64. This 1.64 is greater than the calculated value. That means the calculated value is less than 1.64. Therefore, the hypothesis H naught is accepted. Therefore, the mean height of seniors are greater than the juniors. Thank you.